domain of trigonometric functions. So first we start with two basic functions, y equals sine x and y equals cosine x. So as you see in the picture, sine x is an odd function, so it passes through the origin and it has origin symmetry. Cosine x is an even function, it is y-axis symmetric. And the domain of sine function will be all real numbers, negative infinity to positive infinity, because it oscillates all the way, same as cosine x. So we need to look at some important results, like sine x is 0 at 0, and then at pi, at 2 pi, at negative pi, and negative 2 pi on the left side. On the other hand, the cosine function is 0 at pi by 2, at 3 pi by 2, 5 pi by 2, and on the left side negative pi by 2, negative 3 pi by 2, negative 5 pi by 2, and so on. So based on these results, we can look at the domain of other four functions, and we can see where the vertical asymptotes are for those functions. Now let us look at the graph of tangent x function. So we know tangent x is sine x over cosine x. So when I say cosine x is 0, then tangent x should have vertical asymptote because it is in the denominator. So that's why we draw the vertical tangents at pi by 2, 3 pi by 2, and then on this side negative pi by 2, negative 3 pi by 2 on the left side. Now sine x is 0, you can see at 0. So the tangent x passes through origin here. Sine 0 at pi, so the tangent graph passes through pi on the x-axis, which is 0. So then vertical asymptotes are there. So in this way, you can easily understand that the tangent x has vertical asymptote at negative pi by 2 here, positive pi by 2, and then 3 pi by 2. Also, you can go on the left side, negative 3 pi by 2. So you can continue like this. On the negative side, you have negative pi by 2, negative 3 pi by 2, negative 5 pi by 2, negative 7 pi by 2, and so on the left side. On the right side, you are getting pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, and so on. So at those places, your tangent x has a vertical asymptote. So we'll see another similar where cosine x is in the denominator. That function is secant x. So secant x is 1 over cosine x. We'll have the vertical asymptote in the same places, and then we'll see how the graph looks like. So now in the next part, as you see here, y equals secant x. Secant x is 1 over cosine x. So again, we need to see where cosine x is 0. Pi by 2, 3 pi by 2. So then we are making the vertical asymptotes on this. And then cosine x function is here. The secant x will just touch those points and will go up. And touch this point will go down here. Touch this point and go up here. And then exactly you can see. So where I see here 2 pi, and then this is the point. So in 2 pi, this is the point here, it goes up. So this is your secant x function. And the vertical asymptotes of secant x graph will be again in the same places like tangent x. So you can say secant x has vertical asymptote at pi by 2, 3 pi by 2, 5 pi by 2 on the right side. And on the left side will be negative pi by 2, negative 3 pi by 2, negative 5 pi by 2. And we'll see a similar pattern for these other two functions related to sine x. So now we look at y equals cotangent x, where you have cosine x over sine x. So you just need to see where sine x is 0. At that places we have the vertical asymptotes. So sine 0 is at 0. So this is one vertical asymptote here and also here for cotangent x and for cosecant x. The next vertical asymptote is at pi. So we have here at pi and we have here at pi and so on. Now, cosecant function touches those points, the max mean points. So first here pi by 2, so that one is pi by 2, so it goes like this here. And the next vertex here is 3 pi by 2, so that is at 3 pi by 2, it's going down like this. And the vertical asymptotes. So we understand now where we have vertical asymptotes for other four functions like tangent x, cotangent x, secant x, cosecant x. For cotangent x, we need to look at the zeros of sine functions and make the vertical asymptotes. For tangent x and secant x, we look at the zeros of cosine function and make the vertical asymptotes. I hope this makes sense to you and you have now more strength on talking about the domain of all 6 trig functions. Thank you.